Okay, hope everyone can hear me. Hello, everyone, and welcome to another session of ACE. For those who are new to us, ACE is a online. It was a offline, but now it's an online community focusing on uh, discussions of machine learning research. You could find us on YouTube if you search for ACE or Paper Explained, and you will find we have a lot of we host 3 to 5 sessions every week, talking about latest research, and we invite authors to do technical talks. And we also focus on other areas such as product and other. I think more recently about ethics and basically the human versus computer kind of aspect for topics. Our range of topics keeps expanding, so feel free to check us out at AI.SCIENCE. Um, Today, we are doing a talk, which is, I guess we're sort of diversifying our topic a little bit. So today we're going to we're pleased to have Xun Wang, who works as a data science lead at GEICO. So by diversifying, I mean usually we touch upon technical aspects, but I have been talking to a lot of people recently about data science, the job market, job landscape of machine learning and data science. So you might have probably have heard of a lot of these terms, the different job title, job positions, such as machine learning scientist, data scientist, machine learning research scientist. And personally, I've definitely come across a lot of different job titles, which is, if you feel that is confusing, you are not alone. Um, so um, uh, so today we'll have Xun Wang will give us a talk on his take about the job landscape. Effectively, I think he will give us a map that effectively map out the current situation of the market, and what are some of the ways of navigating them. He will provide with us some I guess essential job profiles for us to have a reference point. So a little bit introduction of Mr. Wang. Xun Wang is a data science lead at GEICO. He holds a PhD in transportation systems engineering from Cornell University and has been working in the field of data science for more than 7 years. He has worked as machine learning engineer, senior data scientist, as well as in data science management positions from his previous and current jobs. With experience in search engines, NLP, sales and marketing analytics, and most recently fraud detection. So without further ado, I'll pass the mic to Xun Wang. Xun Wang, welcome and good to have you.
All right, thanks for having me, Xiyang. Can people hear me? I guess, can you hear me? It's really a question.
Yes.
Can you hear me? Okay, cool. So this talk is about the job profile that I sort of summarized, given the current data science landscape and given my current and past experiences looking for jobs and also hiring people. I hope this will be helpful for first-time job seekers in data science or career switchers in data science who wanted to advance to their second or third positions. So this is essentially the problem that I'm trying to talk about today and give you guys a little bit of a guidance on how to look at the career landscape for data science. So as Xiyang said, I started working on data science about a little over 7 years ago, and I've been a data scientist, been a machine learning engineer. I'm now building out data science teams like GEICO. So 7 years ago, when I first started, everybody was titled a data scientist. And people are doing very different things, but we're all called data scientists. But today, if you look at the job postings out there, you will easily find like a few dozens of job titles that seemingly all says you're doing data science, but you're sort of really just working on certain aspects of data science. And then there are positions that sounded like a data science position, but it's not really quite a data science position. It can get pretty confusing pretty fast. So my central thesis for the talk today is that data science has become a jobs family. So it is not helpful to think there's only a data science position, a data scientist position, or like a machine learning engineer position, but there are rather starting to they're starting to emerge like 5 or 6 job profiles that are sort of handling, that are more specialized positions that are handling more specific aspects of data science. So this is, after some research, sort of my view of the data science landscapes with 7 profiles. One thing to note here is that the names of the profile doesn't really correspond to job titles. I'm really just trying to give sort of an alias to a specific type of job that does a specific set of tasks. So the arrow here also sort of indicates specialization or delegation, because I think a lot of those newer job profiles are coming out of needs to specialize in a specific aspect of data science, and for people and coming from the need for business to have specific positions that are doing a very specific part of the data science workflow. And I've also color coded the 7 profiles into 3 groups. And I roughly think of them as generation 1, generation 2, and generation 3 data science jobs. So starting on the top, there are the data science, what I call the data science consultant and the research scientists that are more common 5 or 10 years ago when the field of data science started. And then as time goes by, they're starting to have more specializations into what I call generation 2 jobs. These are the data engineers that does the data wrangling, the modeling analysts, sort of that are doing more of the analytical workloads, and the machine learning engineer that are focusing on modeling and building systems. And in recent years, as the number of AI use cases in businesses expands, we're also starting to see what I call generation 3 jobs that are more focused on the engineering and the scalability aspects of machine learning systems and machine learning best practices. So in the next 20 minutes or so, I'm going to just quickly go through those 7 profiles to sort of describe what they actually do, where they're coming from, why do people think those jobs are important, and what skill sets are required out of each job profile. And what are some of the typical backgrounds for people to go into the specific job. So let's first start with the generation 1 jobs. And the first one is what I call the research scientist. So those people has been around like forever, even before data science came into existence, right? Those are the computer scientists or the mathematicians or physicists and the scientists that are working on very data-intensive applications, and they're developing data-intensive algorithms or machine learning algorithms. People that sort of give us frameworks like MapReduce, gradient boosting trees, and all this variety of deep learning models that we see lately. So those people are basically like the unsung heroes behind this entire industry of data science, because without their algorithms and open source packages, we wouldn't be as effective or as productive. So those are the people that are focusing on generating general purpose algorithms and frameworks, and they publish a lot of papers into peer-reviewed journals and conferences, but they typically don't deploy or maintain production systems. Now, to be sort of able to work on a job like that, you typically need advanced degrees, not necessarily PhDs, but mostly PhDs in computer science, engineering, math, physics, and biology. And first, when I thought about research scientists, I was mainly thinking about computer scientists that are developing general purpose algorithms. But a friend also yesterday reminded me that there are also a lot of research scientists in other scientific disciplines, in like physics, like people like astronomers that analyzes images of the universe, or biological researchers that are doing drug discovery using machine learning methods. So there are also research scientists out there that are not developing machine learning algorithms per se, but are using machine learning methods to advance their field of study and advance and push for achievements in other scientific disciplines. So I think those people also count as a research scientist in my profile. And those are the people that typically has a lot of domain expertise along with machine learning knowledges. And not surprisingly, you typically find research science positions in either academia or the R&D teams of very large companies, either tech companies or non-tech companies. The second job and the other generation one machine learning jobs, a data science job I want to talk about is what I call the data science consultant. So I don't want you guys to be confused by the word consultant and to think this guy has to be working in a consulting company. Actually, this type of person works everywhere, and was very common in the first 5 years. In the early 2010s, between 2010 and 2015, I would say. And back then, everybody, like I said, those are the people that came from the era where everybody was basically a data science. Everybody was basically a data scientist. And those are the people that are very focused on proving that you can use big data and machine learning models to generate business value in a variety of business situations. So you might remember, like maybe 10, 20 years ago, there are people like statistical consultants or data analysts that are doing similar things like that, with trying to prove business values out of data. I think what is sort of distinct about how the data science consultant or treat those problems, solve those problems, is that there's sort of like an emphasis on mastery of large volumes of data using maybe distributed computational frameworks and the use of machine learning models to generate data-driven bottom-up business insights, instead of in the old days where somebody in business came up with a statistical model with a hypothesis and a statistical model, and then you're trying to fit your model through this top-down business hypothesis or scientific hypothesis. So, and in the chart here, you see a very famous sort of Venn diagram of data science, which basically says a data scientist is somebody with the combination of hacking skills, statistical skills, and domain knowledge. And I think that's a pretty accurate description. You find data scientists still everywhere in the company right now, although they're starting to specialize and evolve into other positions. But you will still find them in the internal data science teams of a lot of companies. There are still a lot of consulting companies out there that have data science practices. There are also customer-facing consulting teams that are in tech companies, mainly those that are selling cloud-based solutions. So data science consultants need to know a lot about machine learning. They do a fair amount of data wrangling, and then then they have to write code. So they have to know programming. They have to understand the business. So they have to have domain expertise and be pretty good at communicating with business stakeholders about their models and their business insights. So up until I think 2015 or 2014, those are really the two data science jobs that are out there. And then things starts to get interesting and specialized, and more specialized. So the first specialization coming out of the data science job family is now the very infamous data engineer. So 5-6 years ago, there's also, you might have heard that there's always a saying in the industry that, well, if you hire a data scientist, he's going to spend 80% of his time doing data wrangling and only 20% of the time actually building models and generating business insights. So back 5-6 years ago, there was this huge push to say, let's hire specific people that will organize the data assets in a company for the data scientists, so that they don't have to spend 80% of their time doing that. I mean, I think now we still spend, data scientists today still spend a fair amount of time doing data wrangling, but it was a bit there was a lot of improvement of our work conditions today, thanks for the big data engineers. So those are the engineers that are basically responsible for building ETL pipelines that assembles raw data from pretty much everywhere in the company, in the data silos of in the companies, and try to sort of sort them, store them, and structure them into standardized data sets and standardized schemas, stored in more of a centralized location or a centralized analytical environments, like a data lake or data warehouses. And those people are typically masters. Data engineers are typically masters of database systems. They have to understand ETL super well. They have to understand data governance, meaning like which team have access to which types of data. They do a little bit of data analysis, and they have to understand architecture to make sure that their data engineering pipeline fits into the bigger picture of the IT organization. There are a lot of data engineer is a very popular job, and in a lot of companies, and every companies today know they have huge amount of data assets they need to organize. So even for companies without data science or analytical use cases, you will still find them to typically have very large data engineering teams. So this is a very popular job with a lot of career perspectives. And it typically takes a lot of people with engineering backgrounds to become a data engineer. But as tools, especially cloud-based tools, becoming more popular and more convenient, I'm also starting to see people with more of an analytical background, especially data analysis or business analysis background, going into the field of data engineering, as well as database administrators. The second specialization coming out of the data science consultant is what I call the modeling analyst. So this job, this profile name might be a little bit strange because you will seldomly see them in an actual job posting. In an actual job posting today, those positions are actually more often than not called data scientist, and that sort of creates a lot of confusion between what a data scientist is actually responsible of doing. So basically, 5 years ago, data scientist was those jack of all trades people that can basically do a little bit of everything. But today, the data scientist positions, or more precisely, as I call the modeling analyst positions, are more focusing on the analytical aspects of data science. So what I mean by that is they're not really producing machine learning systems, but they're building predictive models to generate business insights that may or may not be easy to automate into engineering systems. So a typical example will be something like doing sales forecasts for the company. Sales forecasts are very interesting, are very important for the company, and they're certainly very data-driven. But after you get the sales forecast, it's very likely that those business insights will be carried over by business strategy teams manually instead of being integrated into an IT systems. So you actually have a lot of use cases like that, especially in more mature companies, that requires a little bit of a business analysis and a little bit of modeling. Are now call themselves data scientists, and you can see them everywhere in customer, analyzing customer data, marketing data, user data, even data about the engineering infrastructure. I actually think this is a very sort of good way for entry-level people to get into data science, because all you need to know is a little bit of this statistic and data analysis and a little bit of machine learning. You still have to code a little bit, but you're not going to have as rigorous a requirement as software engineers. And so these positions takes a lot of people with STEM degrees, business degrees, statistical degrees, econ degrees. So they take a lot of people. And I think this is a great way to get into data science in general. The third and last sort of specialization coming out of the data science consultant, which is a very hot job position right now, is called the machine learning engineer. So this is the type of people that are more focused on building machine learning systems that generates predictive insights on a 24/7 basis continuously. One of the limitations of the prior data science consultant jobs is that people feel like oftentimes their business proposals and their modeling results just ended up on the PowerPoint slides, which looks pretty for probably 5 days, but then you still need to figure out ways to implement them. Machine learning engineers typically work on the more tactical side of data science. It's more like, I have a business insight. Now I need a system to automatically implement it and mine the data to find out the business insight and push for actionable results and predictions to the rest of the company. So as this title suggests, a machine learning engineer is a bit of a hybrid between a modeler and an engineer. So they implement a lot of models, but they implement it in a way that is very rigorous, that has bad software engineering practices. It was actually a bit of a tricky job to get into, because data science is all about creativity, but engineering is all about not making mistakes. So a very good machine learning engineer needs to strike a very good balance between those two aspects of his job. When you are a machine learning engineer, you're obviously expected to know a lot about machine learning, especially deep learning nowadays, because this is where the engineering difficulties comes in. You need to understand software engineering. You still need to do data and business analysis, and the business stakeholder will still ask you about the business results that your machine learning model generates, and you need to understand the system to be able to integrate that into the rest of the IT organization. There are a lot of machine learning engineering teams, especially in tech companies and startups right now, so they're hiring a lot of people like that. There are also IT consulting companies that hire a lot of machine learning engineers. And generally, just any other company with large IT system that generates a lot of data realize that they could probably use the help of a machine learning system to optimize their operations. And you're seeing data scientists, research scientists, software engineers, and data engineers all going to pursue this machine learning job that's pretty popular right now. So let's take a look at this Venn diagram of machine learning engineer again, and you notice that besides data science, it also requires a lot of support in DevOps engineering and software engineering. And that's sort of where what I call the generation 3 jobs comes in, and it's getting a lot of momentum in the last 2 or 3 years. The first profile I want to talk about in the generation 3 is what I call the MLOps engineer. So people are very familiar with DevOps. This is basically a discipline to make sure that you have that sort of combines development and IT operations together. And especially nowadays, DevOps engineers typically leverage a lot of the existing tools from cloud providers to provision hardware systems and monitor software systems for the IT organization. So an MLOps engineer is basically a DevOps engineer that specializes in machine learning engineering use cases, that they understand the unique challenges of data science workloads, like cost effectiveness, scalability, elasticity, and data security. So some of the examples I can think of that an MLOps engineer do a lot, but a regular DevOps engineer wouldn't do. The first one might be testing. Testing data science models are a fairly interesting topic, because data science machine learning model needs a certain critical mass amount of data to test the actual accuracy of the model. But in a typical engineering testing environment, people don't store a lot of data. So the smart and experienced MLOps engineers will be able to make those arrangements to make sure that the machine learning engineering teams has enough data has adequate amount of data to test the quality of their model. The second aspect also concerned that's unique to MLOps is that model training uses very expensive hardware resources, but typically we don't use it 24/7. We use it on an on-demand basis. So we have very spiky demands for a lot of computation resources in like a span of 3 or 5 hours, but we need to throw those computation resources away because otherwise they will be costing the organization a lot of money. Now, a good MLOps engineer will be able to craft a plan to sort of summon servers from cloud providers on demand and to turn them off as soon as the job finishes, and to also schedule additional jobs when failure happens. Obviously, if you're a DevOps engineer or MLOps engineer, all the cloud providers, AWS, Azure, or GCP are your friends. You need to know them in and out. You have to understand computer networks, distributed systems, and a little bit about machine learning, preferably. It's a pretty hot job right now. There's a lot of DevOps engineers, data architect, data engineers, and network engineers that are going into this field, and thinks this is a relatively new job. This is still being very short supply. we've been, I mean, everywhere I go, people have been trying to hire very good DevOps engineers to understand the machine learning engineering ecosystem. And it's always a challenge to hire the right people with the combination of ML understanding and DevOps experiences. So the last job title I want to talk profile I want to talk about a little bit is called the ML Platform Engineer. If you look at this chart here, this is a figure from one of the papers published by Google 5-6 years ago that basically argues that in order to have a successful machine learning system, ML the actual machine learning code is probably 10 or 20% of the job. You have to surround the machine learning code with all sorts of other supporting systems, serving infrastructure, monitoring systems, for example, configuration system, model analysis system, to make your machine learning ecosystem really robust and productive. With the help of DevOps engineers and the offerings from cloud providers, today you can typically get 80% of the job done by using offerings from cloud providers such as AWS or Azure. But there are always going to be edge cases where you want to build something that's more customized that you couldn't really just buy from AWS or Azure. And this is where the platforms engineers come in and build those systems for you. A very common module that platforms engineer builds and maintains are like feature stores. So those are the system that can store and define the features that you use in the machine learning model, so that it can be reused and retrieved by other teams that didn't invent the feature in the first place. There are other examples of platforms that ML platform engineer might want to build are like systems that collect streaming data in real time, or like systems that are sort of monitoring the performance of ML systems, or providing version controls for ML models. But there's typically a lot of demand for platform engineers today, as the IT organizations, as the machine learning operations of every company scale and reaches a lot of the areas of business. And sometimes, there's our needs also to support for a platform to support teams without a lot of technical backgrounds. ML platform engineers are very, very similar to just regular backend software engineers, but what they want, the skills that we want from them in addition is understanding about machine learning and understanding about data engineering specific. And they typically work very closely with data science and ML engineering teams in a variety of IT organizations. And you tend to see them a little bit more in large IT companies than smaller, more traditional companies. So we talked about all 7 profiles now, and I don't know how many you still remember by now. So I like to sort of recap it by using sort of a sweet analogy. Let's imagine we're in the business of making chocolates, and let's sort of think about what each of those 7 profiles will play in the success of a chocolate business, of a chocolate factory business. So the research scientist will be like the food scientist that discovered the recipe to craft delicious chocolates. And then the data science consultants are basically the entrepreneur that created the first batch of chocolate from her backyard and secured a sales contract. So the emphasis here is that it showed business value. And then the data engineers are sort of like the farmer that supplied the raw materials to build to actually manufacture the chocolate. The modeling analysts are the general manager that are in charge of business strategies. Maybe he wanted to understand how many chocolates we can sell every year, or what flavors of the chocolates that our customers really want. The ML engineer is the guy that said we can't really build that many chocolates from the backyard. We have to have an industrialized mass production process, and we're gonna be designing and building that. And then the ML ops engineer are the facility people that basically give us all those industrial equipment. And then after we build the mass production pipeline, he also sort of oversees the production process for us. And a platform engineer will be like the operations manager that sort of develops efficient supply chains and manufacturing procedures to make sure that chocolates can be produced in a very efficient manner. And after they're produced, they can be distributed to all the customers and buyers in a very efficient manner as well. So that sort of caps off my sort of introduction of the 7 job profiles in data science. Just probably have some final remarks for people that I know that there are a lot of career seekers there that are trying to tap into data science, or you're leading data science and you're trying to reach for another job. I think the thing you want to remember first now is that this year in 2020, the field of data science now demands a very diverse group of professionals with relatively specialized skill sets. And I think becoming a data science unicorn, which is somebody that knows a little bit of everything, is becoming increasingly less practical or even necessary, because you really need to be really good at 1 or 2 areas of data science to be a productive member of the team today. And also, data science is also a very welcoming field, and you can work on data science even without working at a data science specific capacity. There are product managers, people from marketing and sales, and regular software engineers that can all contribute to data science. So if you're interested in data science, there's always plenty of opportunities around you, either online or in some of your offline communities that you can tap into to go into data science, or sort of go into a specific aspect of data science. And as job titles and career trend has changed over the past 10 years, the career trend and job title will definitely going to change again. The job profiles I talk about today is probably going to change. It's probably going to evolve a lot in the next 3 or 5 years. So what do you want to do when you have a field that is constantly changing and evolving? I think the best suggestion I can have for you guys is to always think about what are the hard problems for business to solve, and then sort of put yourself in a position to solve very hard, impactful problems. 10 years ago, that problem was proving that machine learning models can generate business value, and we've proved that already. 5 years ago or 3 years ago, the problem has the hardest problem is, how do I productionize a machine learning system so that I don't have to generate those insights manually? Today, the problem is I have 5 or 10 data, I have 50 or 200 data science use cases across the company. And how do I use a platform to support it more efficiently? Tomorrow, the challenge might be, I want to build a robot to do everything for me eventually. And the hardest problem in data science changes every year. But as long as you have a sense about where the hardest problem is, and you put yourself and put yourself closer and as close as possible to those harder problems, you will always have a very fulfilling and very fruitful career. And that concludes my talk. It probably takes a little bit more time than Xiyang wanted to be, but I guess now we can take some discussions and take some questions.
Oh yes, that was perfect fine, and thanks a lot for the talk. I definitely learned a lot, even though a lot of those things look very familiar as a startup. I guess working at a startup, I definitely see myself doing a lot of those things, but I never thought very carefully about, number one, where the boundaries are, and number two, how those things are actually categorized. And that cleared things up a lot. I really like the lineage and how you define those 7 job profiles. And now we have some questions already lined up in the audience. So, but before that, I have a couple of questions that I was wondering. The first one is, you mentioned these profiles, but I wonder how the jobs, like the scope of responsibilities, are distributed differently in terms of big company versus small companies. Like, for example, like, is it the case that for smaller companies, like, usually these roles, like, people might take on multiple roles, and in bigger companies, and you have more specialization? Or do you have any comments on that?
Right. I think this is a really good question. So let me just go back to this slides that sort of listed all the job profiles. I think if you're going to a specific company today, you will likely find, excuse me, a subset of all of those job profiles or job functions in a company. It's not necessary that every company is always only have generation 1 job or generation 2 job, generation 3 job. The most likely scenario is that you will find a little bit of everything in every company. I think small or large company is probably, it's a helpful way to think about it, to sort of try to segment how data science teams are organized internally. But typically, I tend to think of it more as along the dimension of what I call analytical maturity. So this is sort of basically a qualitative measure of saying how comfortable your organization is with data science and analytics, how much experience you've had, and how many tools and systems you've already built in place. So small startups sometimes has very high analytical maturity if analytics is all they do. So in small startups, you will be able to find a lot of those generation 2 and generation 3 jobs. For larger companies, for large tech companies, they definitely more specialization, and they probably have those specializations much earlier before they're populated into the rest of the industry. But if you look at a large company that are sort of in more of a traditional space, maybe finance, maybe pharmaceutical companies, or maybe retail companies, you will find that the boundary of those positions are a little bit blurry. That's sometimes also because that those companies themselves are still in the process of identifying the analytical organizational structure within inside of it. And you will find, and in those situations, they will sometimes prefer that you have to actually not hire very specialized people because they wouldn't know how to utilize them. Sometimes we would probably prefer hiring people that are a little bit more versatile, that can do a little bit of everything, so that those people can bridge the gap as they sort of go up of the analytical maturity curve. And when you are in a traditional company, typically the data science department tend to be a little bit smaller. It tend to be is housed under certain business functions. And the team, when the team gets smaller, specialization is harder. And so you can also find those teams and those people needing sort of more versatile players instead of any of those seven very specialized positions. So I think it depends a lot on the analytical maturity of the organization, and the size of the company is a sort of like a correlated factor. But I don't actually think it matters a lot in terms of how those positions are organized internally.
Okay, thank you. So let me take a question from the audience. I think Ganesh asked, if I could rephrase his question, I think what he's asking is, you mentioned all these job profiles. It appears that most of them requires some level of understanding of machine learning and machine learning and data science, right? So his question, I think what he's asking is, if you excluding the research scientist kind of job that requires like very clear understanding of the model, would it be sufficient to learn, say, how to run scikit-learn, run a black box machine learning model, say for example from scikit-learn, TensorFlow, or pre-trained model, and just call maybe model.fit to train it? Like would that level of knowledge be sufficient for any of these jobs?
I think there are definitely opportunities there. So out of those 7 profiles, you actually see that there are jobs that technically doesn't require a lot of machine learning experience at all. Like data engineers, I hardly think that they need a lot of machine learning experience per se. And for the ML platform engineers or the MLOps engineer, they really just requires fairly basic understanding of machine learning. So I guess interesting when you think about how much modeling knowledge or experience that somebody like a machine learning engineer or data science consultant actually needs. And I think the answer is that it kind of depends a lot on your level of experiences, and sometimes depend a little bit on the use cases, the business use cases that you're solving. There are a lot of there are a lot of data science use cases that actually are not very technical or uses very sophisticated machine learning models. Oftentimes, all you really want is people that have very acute intuitions about data, or in some very domain specific business problems. They will also probably prefer people with a lot of domain experiences, let's say in finance or in biology, or in drug discovery. In those use cases, I think, I mean, using sklearn.fit, it can probably get you quite a bit out there in terms of solving your problem. But I think as you level up, especially as you go beyond just building the first version of the model, your sort of requirement for understanding the inner workings of the model increases over time. Because once your models are in production, I mean, more often than not, it's always going to make mistakes. Even if you think 95% accuracy is great, the business might be asking 99% accuracy implicitly. So you're always going to get complaints about, oh, why does this model doesn't work on this specific subset of data, or like why is it behaving? Why are the correlations between the feature and target not something that makes intuitive sense from a business perspective? So I don't think it's really in the model training stage, especially for the easier problem that you need a lot of understanding about the machine learning models per se. It's really when the model goes into operation, and when you're dealing with customer demands, or you're trying to sort of maintain the model, you're trying to debug the model, you're trying to evolve the version from V1 to V2, and you want to understand how the model behaves so that you'll understand what to improve in that V2. I think it's in those later term issues, later time considerations, that you will gradually feel that if I just treat the model as a black box, I'm not going to go super far. So I think the overarching question is that it depends. I always say there are a lot of entry-level jobs that probably, having basic understanding of machine learning, especially coupled with strong engineering skills or strong domain knowledge, can get you fairly far. But in order to actually be like sort of a lead data scientist, or like the go-to guy for a machine learning system or a data science project, I do think you want to gradually try to build up your knowledge about modeling and data science, modeling and machine learning in general.
Okay.
Yeah, that's a good question.
Yeah. Okay. And then yes, and then that's a good answer too. So, I really like what do you talk about the dynamic aspect of it. It's not like you have a plan, and then you just execute it. Like, I guess the phrasing another way, if I could, like I came across this quote today. I think it's by Muhammad Ali. He said, I'm paraphrasing. Yeah. He said, all plans go out of the window after the first punch. Right, so it's really about if I understand it correctly, it's really about understanding the inner workings so that you can be fully prepared.
Yeah, there's some aspect to that too, because data science projects are very unpredictable compared with other business projects or IT projects. You're always in uncharted territory. So, and you're always sort of and you're always dealing with a lot of uncertainty or unknown. So basically, I can use an analogy here. So basically, so this question about how much machine learning people would need to actually be successful in a career is sort of, in a data science career, is sort of asking how much inner workings about the car do I need to know. to be a good driver. I think if you live in a civilized country where the roads are all flat and wide, and you can find gas stations and mechanical shops everywhere, then you don't require to know a lot about the engines or the inner workings of a car to be a good driver. But if you're out there in the field and they're trying to maybe in some remote area trying to charter your way out of a desert, I think you gotta have much better understanding about the car to make sure it really functions and doesn't break down in the middle of nowhere.
Okay, cool. So we have a lot of questions like keeps piling up. So let's just move on to the next one. Next one is from Prashant. He was wondering how much of the machine learning engineer's profile relies on past data science experience. In other words, is it natural for a data scientist to transition to a machine learning engineer role at a later stage?
I actually did that personally myself. So from a sample size of 1, I would say that is a very that is probably a very promising career path to go into. So when I first started out doing data science, I was building a lot of predictive models, and then after a couple of years, once I got to a certain understanding about models, and then I started to wonder how I can make the ML models more scalable, or how can I make the operations more efficient. So I applied for a machine learning engineering job. Well, the title is still called a data scientist, but now all my colleagues are basically software engineers. I work with them to build systems. I'm more responsible for the machine learning part, so maybe the training pipelines or the scoring pipeline. And they're responsible for like the data ingestion pipelines, the actual APIs to the model. And I work with them a lot. I think when I was working with them, the dynamic was really, really good. I treat them as the expert in engineering, so everything I have in programming and testing, I just ask them and pretend like I don't know anything. And there are also a lot of very good software engineers that sort of doesn't have a lot of intuition about data or machine learning. So every once in a while, I also sort of try to relate to my experiences in data science into more of an engineering context. So I think that the dynamic is really good, and I think I learned during my work experiences we learn a lot from each other. So I think it's definitely a very good career path for people to go into, for data scientists to go into machine learning engineering. I think probably typically the bar you have to pass is a certain proficiency of software engineering. I think somebody told me, like, for using Amazon example, Amazon has a job title called research scientist and a job title called applied scientist. And somebody once gave the analogies. So an applied scientist is somewhat close to a machine learning engineering job. And somebody once told me that the difference between a research scientist and an applied scientist, that applied scientist can also double as a software engineering level, as a level 1 software engineer. So that gives you sort of like the sense about the type of technique that they're looking for. So generally, I think there are way more good engineers out there than there are for people that has okay engineering skill but a lot of data science experiences. So if you're able to pass the engineering bar and to be really humble about your ignorance about engineering and technology, I think you will get along very well on the machine learning engineering team and working with a lot of software engineers, because after all, we're all technologists, we're all very logical, our thinking patterns are very similar, and we can learn a lot from each other.
Okay, cool. I never thought. Okay, thank you for bringing perspective from the other side. I guess for myself, I was a software engineer transitioning into a machine learning engineer role, so it's good to have that the other sample size as well. Okay, so another next question is also a good one. So, is there any tips on how to get some domain knowledge of any field for data science?
To get domain knowledge?
Yeah.
Well,
Yep.
I mean, I guess domain knowledge is the sort of thing, I guess, unfortunately, that's a little bit harder to acquire through like online materials. So unlike engineering skills or data science skill, where there are a lot of open source materials, I think the best way for you to learn anything about particular domains to join a company or like a research institution that specializes in that domain. So I joined GEICO because I have an interest in insurance. I want to understand what it is about. So instead of reading books, I decided to just join them from the inside and understand more about it. And it's typically a pretty cost-effective way to acquire domain knowledge in any industry. And a lot of domains by definition have plenty of domain experts. And a lot of domains now understand that they need people that need the help of data scientists to sort of leverage their data assets. So again, this is sort of analogous to the data scientist plus software engineering 1-2 punch. This is another very sweet sort of sweet spot 1-2 punch between a domain experts and the data scientists for you guys to learn from each other. So I think as long as you can find a company that sort of specializes, that works in the domain that you're interested in, just get in there and say, how about I teach you data science and you teach me about this domain? I think typically you will find that people typically think that is a pretty good deal.
Okay. So the next question is, I guess we covered this partially, but the audience is wondering that this person is asking, is there any? Oh, okay. Sorry. Let's move on to the next one. He just deleted his question. So, if you are new, if you're early in the career, like you haven't specialized in anything, is there any tips for getting hired before doing specialization? Or I guess it feels like a chicken and egg problem. Like, do you need to prepare yourself to specialize in order to get hired, or is there any way for you to get hired first and then specialize?
That is such a good question. I guess I'm in the field for too long, but I'm starting to forget how I got into the field in the first place. Do you need? I don't think for entry-level people, I don't think you need a lot of. I mean, it's not necessary nor possible for you to get a lot of specialization coming right out of school. I think specialization are more for people that are moving from entry-level job to their second job or their third jobs. I would say if you to think about how to break into the field. I mean, like I said, data science is a very broad area that basically have some footholding in most of the industries. So if you don't know about data science, you gotta know something, right, from your college degrees or from your master's degrees. Either it's knowledge about a specific domain, or is data analysis skills, or is engineering skills. I think you want to play it to your strength and try to find a position that utilizes your past, that sort of values your past experiences a lot. So I think my personal example, but now I think about it, I got hired on my first job because I had a PhD in and I did a lot of research in statistics and mathematical programming. So I'm pretty good at doing data modeling. So that's what got me into my first job on modeling. And on my second job, like I said, when I was talking about the machine learning engineer, I was basically the data scientist that respects and knows enough about software engineering for the engineer to be comfortable talking with me. And then on my first job at GEICO, I was basically the data science expert that's been doing a lot of, that's been in the field a lot and has experience developing systems and developing teams. So I think every time you want to switch your job, regardless whether it's your first job or your second job, you want to find something that you currently have that your next employer probably doesn't have, and you want try to sell yourself to them about the values of that. So coming back to like the real entry level people that and that want to get a first data science job, I always think about the fundamental quality or the data science 101 quality of anybody that wants to break into the field as your intuition about data. So you don't have to build very complex models. Models are more sort of secondary artifacts of your analytical ability. But almost every field today deals with data, and to be successful in solving any problems, you have to analyze tons of data and present your data analysis insights to like whatever business stakeholder or your future employer. If there's one thing that I would think that I think everybody already have, or you probably don't know that you already have, is your ability to be analytical, to analyze large data set and derive business insights from it. I think that's fundamentally the most important quality for a data scientist. And whether you build a machine learning model or a machine learning system to materialize that is really very secondary, because you have to start with very good data intuition to break a business problem down to a modeling problem. And I think a lot of people in a lot of fields actually do that on a daily basis. You just need to understand how to sort of sell that as something really valuable to your employer that are hiring data science positions.
Okay. So the next question is, I think it's kind of related back to the profiles, but it's thinking from another perspective, I guess. Suppose you want to become a machine learning engineer versus data engineer versus, say, research scientist. What type of projects should I have in my resume if we want to get into those respective positions? Like what are some of the typical like good projects to have in the resume?
Good question. That's really hard to generalize across all the 7 profiles. So maybe we can mention them one more. For research scientists, you definitely need to have publication records in sort of data science related subjects. For data science consultant, I guess we're looking for a lot of experiences where you sort of generated business value for the business by utilizing data and modeling. Data engineer, I'm not super familiar with the job, but I'm guessing like a lot of experiences that organizing data or sort of ingesting raw data and transforming them into more structured data assets are definitely very, very useful. Machine learning engineers is kind of close to data science consultant. You want to make sure that you have experiences building systems that are generating business value. But I think there's also probably a lot of requirements on your engineering skill set, so you can just build a model and present to your business stakeholder in the PPT. You can show that you can work with software engineers to build systems. Speaking of PPTs, I think all analysts shouldn't shy away from PPTs. So if you did analysis that ended up with very beautiful data visualization charts, and you've generated business insights, not necessarily actionable insights, because that's more in the ballgame of a machine learning engineer, I think that would be good. Platforms engineers and MLOps engineers are really just machine learning variants of DevOps engineers and platforms engineers. So for platform engineers, you just want to have a lot of experiences building mainly backend systems and maybe front-end systems. I think it was more backend systems, and you want to show some interest or basic knowledge of machine learning. So maybe you can say, I helped this machine learning engineer sort of debug his systems, or I generate some metrics for him. Or you can say on the side, I was taking some machine learning courses and doing some side projects just for fun. And MLOps engineers is basically DevOps engineers. So you want to have a lot of experiences managing infrastructures, managing workflows, and again, you want to have some interest or knowledge in machine learning, preferably. Yeah, that's pretty sort of a quite a sweeping generalization, but I think that I hope that helps.
Okay. Yes. Actually, we are kind of running out of time. So, um, to conclude with one more question, which is also
Sure.
kind of related to the previous question. Given like say looking at resumes one aspect, you also kind of mentioned the interdisciplinary nature of data science, and so there are, I guess, multiple entry points to get into. But I think if you could kind of summarize from a manager's perspective, like suppose you are hiring, what kind of qualities do you look for your candidate, just generally, like generally speaking?
Also a good question. I guess I was mostly involved in the hiring of positions like that are more like a data science consultant or machine learning engineers or sort of like somewhere in between. I think, and people like, and I think ultimately, I mean, the top one indicator on the resume is always very good experiences, and believe it or not, is very well articulated experiences. Because I read articles and a lot of recruiters agree that just by the way you're describing your contribution to the project says a lot about what you value and what you're learning from your work experiences. So believe it or not, and it's not really the quality. I mean, it's the quality of the project helps, and if you're working in a very reputable company, that definitely helps. But when you don't have a lot of that, I think it's the way that you're describing the project. It's the way that you're communicating what's really valuable to you in these work experiences, and that will help you a lot, and into getting a positive experiences for the hiring managers. So besides experiences, I guess I mean I always look for basic understandings about programming, software engineering, and modeling. These days, and increasingly so, you can't really just get by using either. So if you're a very good software engineer that knows how to call SQL and APIs, I will probably not hire you as a priority. If you are a modeler but doesn't know how that uses R or SAS a lot, but doesn't know how to write a proper software, proper code repo, you probably would not be on the top of my list either. I'm looking really for very balanced players that exhibited that they have a little bit of a they've passed a certain bar in both of those areas. Yeah, and that's really it based on what I can see and on the resume. I mean, school and the reputation of the programs, I think they help a lot when you don't have a lot of experiences. But when you have like 3 or 5 years experiences, they tend to matter less and increasingly so. Yeah, but overall, outside of the actual thing that you listed on the resume, during my interviews and my communication with candidates, I'm always looking for what I would call the very curious learners. I think data science is such like a green field that everything changes, and what you learn today may not be valuable tomorrow. So you really need to have a lot of curiosity to learn about new things. And I want to see evidences that you have successfully learned a great chunk of knowledge on your own, and you have applied those knowledge in either your academic experiences or work experiences. So that's really just it. I mean, on the high level. And yeah, besides that, any specific experiences that sort of caters to the project that we're doing definitely help. But if I see very smart candidates that I think have very high potential, I tend to not care too much about whether his actual project experiences fits a lot with what my team is doing.
Okay. I think that's all the questions we have, and we're also running out of time. So, definitely lots of good insights. And I think the most value I took from this talk is like there are a lot of good ways of thinking about these things. We heard of these terms, but you gave us a good analogy profiles and all of different ways of thinking about the boundaries, and definitely a lot of insights from a either a management perspective and from a people who has been working in this field for quite some time. So with that, I'd like to thank you, Xun Wang, Ms. Xun Wang, very much for coming to our platform and sharing his insights. And if you're new to our channel, please make sure to subscribe, ML Papers Explained, and check out our website for future events. We have quite a lot of events lined up, probably 30 or so in the coming month. Thank you very much, and everyone have a good day, evening, depending on where you are. Thanks a lot. Goodbye.
Thank you. Thanks for having me.